we were on primary amines that have this particular formula. So primary amines, this amine group, the NH3, okay? The NH3 group. The NH3 group is actually the amine group. So this is to be a primary amine. So primary amines, like I was saying, they're just like carbon atoms. If one group is attached to them, a carbon atom, if only one carbon atom is directly attached to them, they will be known as primary amines. So you have NH3, then here now check the atoms that can attach to this particular carbon. So you have 5 carbon atoms, so it can be 1 here, 2, 3, 4, 5. This is your structure, 1, 2, 3, 4, 5, and then it comes to this particular group. Now, because only one carbon is attached to the amine, these are known as primary amines. You can make a cyclic these are 5 carbon atoms like it is there, and then they attach to the nitrogen like this. This amine will still be a primary amine. CH2 there, sorry, CH2. Okay, so this will still be a primary amine. Why a primary amine? Only one carbon atom is directly attached to the nitrogen atom. So if 2 nitrogen atoms, I mean 2 carbon atoms are attached to the nitrogen atom, it is a secondary amine and not a primary amine. So this is a secondary carbon that is attached to a nitrogen. That this doesn't mean this is a secondary amine like it is with these other groups. When you're looking at alkyl halides, you're looking at alcohols, we will say what type of carbon are they attached, and then we classify them depending on that particular carbon. With these, that's not what we do. For them, we look at what carbon is attached, how many carbon atoms are attached to the nitrogen. That is what is used for classification. So you can come up with many other remaining types of carbon atoms which can only have one attaching itself. Now check. Everything should match. Hydrogen should be 13. Here you have 3 at the far end. You have 3 plus 2 here, plus 2 here, plus 2 here, and plus 2 there. So you have 2, 4, 6, 8. Okay, 2, 4, 6, 8. And then 8 plus 5 is 15, because here you have 2. So 2, 4, 6, 8, 10, 13. This matches that description. You come to this one. This one will not match the description because it is cyclic. Unless if your IHD calculation was 1, then you can say you have a cyclic molecule like this. So this won't match. So check, you have 5 carbon atoms, but you have 2, you have 2, you have 2, you have 2, and you have 1 there. So 2, if you count, 2, 4, 6, 8, 10, 11. You have 11 carbon hydrogen atoms that doesn't correspond to that formula, meaning this is not your structure of interest. So not cyclic, because cyclic should give you an IHD of 1. So since we have no double bond, there is no need for that. So the other structure you can do is you can do that, and then here, that is where you can put the nitrogen if you want, like that. If you check this one, you have 3, 6, 7. All right, you can count. You have 3 here plus 3, that is 6, plus 1, that is 7, plus 2, you have 8, 9, and then 10, 11. This also doesn't match. You have 3, you have 3, you have 1, 1, 2, 3, 4. Oh, no. The hydrogen atoms were less. Now it counts. 3, 3, 3, 9. No need of putting there. Plus these 2 here. It's 3, 3, 3, 9, plus 2, 10, 11. Plus these 2, 12, 13. So this can be another formula. You can just have a cyclic like this, 5, and then you change the position of the amine group. You put it there, and it will still give you the same. So you can do these rotations, this kind of rotations, this kind of changings, and at the end of the day, what you're going to have is going to be an amine that is going to be still primary. Okay, and we go to 7. Hopefully that is clear on amines. An aldehyde or a ketone with 3 carbon atoms. An aldehyde and a ketone with 3 carbon atoms. Okay, so an aldehyde and a ketone with 3 carbon atoms. 1, 2, 3. The aldehyde is going to be here, cyclic like that, H like that. You have this, an aldehyde and a ketone with 3 carbon atoms. So this is an aldehyde that you're going to have. For a ketone, it will be like that, and then you group there like that. So this is an aldehyde, and that is a ketone with 3 carbon atoms. Okay, so that is how those particular questions were supposed to be answered. And then from here, we can actually come to question 7. And with question 7, I only do one question, and the rest you will do. How many carbon atoms are present in the longest continuous chain in each of the following? So the longest continuous chain, I'll deal with H. So you start counting for H. Here you have 1, you have 2, you have 3, you have 4, ish. You have 4, you have 5, you have 6, you have 7. That is one alternative. Or you can say you have 1, you have 2, you have 3, and then this becomes 4, this becomes 5, this becomes 6, this becomes 7, this becomes 8. Okay, that is it's changed everything though. Okay, so you have 8 here, you have 7. If this was where you wanted to end, then this is going to be the longest. Or you can try going the other way. You have 1, you have 2, you have 3, you have 4, you have 5, you have 6, you have 7, you have 8, you have 9. So this has 9 carbon atoms instead. So if you check, you have 1, 2, 3, 4, 5, 6. Then you have 1, 2, 3, 4, 5, 6, 7, 8. So going any other way you would want doesn't give you a number that is above 8. It's a continuous carbon chain. So here, the longest carbon chain is going to be that one here. This one like this, and then it goes like this, and like that, and like that. The rest of the molecule that remains are substituents. So you can try also to do the rest of the questions because they are simple and they are using the same principle. Here, you just need to discover the longest carbon chain. And then, yeah, so here my longest chain has 9 carbons. Okay, it has 9 carbons. I hope that's enough for today. Any questions? If none, we meet tomorrow to continue where we have ended today.